Hello everyone. Today let us discuss about circular motion. Today's our topic is circular motion. So let's start our discussion. What is a circular motion? It is simple. If a particle or a body moves along a circular path, we call it as a circular motion. Many children play in the playgrounds. They all move in circles, and that's all nothing but circular motion. If any body moves in a circle, we call it as the circular motion. While moving in the circular motion, if it goes with the uniform speed along the circular path, then we can say that the particle is in uniform circular motion. So you can see this is the circular motion. But at the same time, if the body moves in a circle with a uniform speed, then we call it as uniform circular motion. And most of the things in our universe, they go in circular motion. If you say, for example, a fan moves in circles, and you can say a potter makes the pots, then the pot makes rotational motion. Of course it is rotational motion, but the particles move along circles. Like that we have so many examples. Many things move in circles. So when something is moving in circles, we call it as the circular motion. And uniform circular motion is nothing but when it is moving in the circle, if it follows a uniform speed along the path, we call it as uniform circular motion. Now let's see the velocity for a body in a uniform circular motion. Let us derive the expression for the velocity of a body which is moving along a circular path. So you can see here a body starts here at A, and then it was moving in anti-clockwise direction like this. After some time, let us assume a small time dt, the particle has come from A to B. The particle has come from A to B. Now let us join A with the center of the circle O and also B with the center of the circle O. The angle which it made is d theta. It is d theta. So in this for a time dt, the particle has gone from A to B, and it makes an angle d theta at the center. And we all know that AB is the arc. If the circle is too small, we can take the straight distance AB as almost equal to the arc length AB. We can think like that because if the circle is small. So now when the object has moved from A to B, I already told you it makes an angle d theta. So let d theta and dx between A and B the angular and linear displacements. Linear displacement is along a straight line AB. Angular displacement is nothing but the angle which it made during the time dt. Earlier it was at A, now it has gone to B. In between A and B, the angular displacement is d theta and the linear displacement is AB, which is dx. Now let smaller be the radius of the circle, that is circular path where the object is moving in a circle. O is the center, A is the initial point, B is the final point. When it has moved from A to B, it has made an angular displacement of d theta and a linear displacement of dx. Now we all know the fundamental equation velocity is equal to displacement by time. This we know from the beginning. Velocity is equal to displacement by time. Therefore, V is equal to displacement is from A to B in a time dt. Therefore, V is equal to dx by dt. That is what we have written here, which is equation number 1. Now, after that, we all know angle theta is equal to arc by radius. Arc means AB, radius is R. But AB is equal to dx, therefore dx by R. Therefore, we get, that is, angle, for small angle we are taking as d theta. D theta is equal to AB by R, but AB is equal to dx by R. So this is equation number 2. So now we have seen equation 1 and 2. Equation 1 is this one, that is V is equal to dx by dt. Angles, equation 2 is d theta is equal to dx by r. Therefore, from this cross multiplication, dx is equal to r d theta. Dx is equal to, from here you get dx is equal to r d theta. Substituting this equation 3 in equation 1, we get V is equal to R, and then dx means r d theta. So in place of dx, we are writing r d theta. In place of dx, we are writing r d theta according to the equation 3 and divided by dt. We can write this as r d theta by dt, but d theta by dt is called as angular velocity, which is given by the Greek letter omega. This is called as omega. This is not w, this is a Greek letter omega. So d theta by dt is called as angular velocity, that is equal to omega. So therefore d theta by dt you replace with omega. Now you will get V is equal to r omega. This is what we want. So finally we have arrived at the expression that V is equal to r omega. In this expression, V is equal to r omega. V is the linear velocity, r is the radius of the circle, and omega is the angular velocity. Omega is equal to d theta by dt, that is angular displacement by time. So let's continue our discussion in circular motion to calculate the centripetal acceleration. Any object when it is moving along a circle, there is always a force working towards the center. That force is called as the centripetal force. And every force is multiplied with acceleration with mass. That means there is F is equal to ma, we all know that, where A is the acceleration. The force which is pulling the object towards the center is called as centripetal force, and the acceleration towards the center is called as the centripetal acceleration. Now we have to derive the expression for centripetal acceleration. Let us derive the expression for centripetal acceleration. So it is the acceleration of a particle moving in the circular path. The direction of this acceleration is along the radial line and always directed towards the center of the circular path. So what does it mean? It means that if something is moving in the circle, there is an acceleration always working towards the center towards the center, and it is along the radial line, that means along the radius everywhere, like this, and the direction is always towards the center. If O is the center, direction of this acceleration is always towards the center. Now here in this figure, if you can see here is O is the center of the circle. We did not take the full circle, we have taken only one part of the circle. Suppose if you extend it, it will become like this. It will become a big circle like this. But we have taken only a part of the circle whose radius is R and whose center is O. Now the object is moving from A to B, it makes an angular displacement d theta. AC is the centripetal acceleration. Here it's working towards the center. Dx is the linear displacement. And at A it has a velocity VA bar, and at B it has a velocity VB bar. So let us consider a particle moving with constant speed V in a circular path of radius R with center O as shown in the above figure. So you can see here it's moving in a circular path with constant speed V, and in the circular path the radius of the circle is R and the center is O. That is shown in this figure 1. Now the same figure we have redrawn with the vectors, with the vector notation. We have to understand now VA and VB, it is going with constant speed we said. That means VA in magnitude is equal to VB in magnitude, but their directions are different. What are their directions? Their directions are separated by an angle. Let us see by an angle. What is that angle? Let us see now. So now if you take VA in this direction, and we know from vectors V minus VA will be in the opposite direction. This is minus VA bar. If your VA is in this direction, minus VA will be with the same magnitude but in the opposite direction. So now we have taken minus VA here, and then VB we have taken here. You can see here, we can see here, it makes a triangle. The head of minus VA is here and the tail of VB is here. The tail of VB is touching the head of VA. That means according to triangular law of vector addition, when the tail of VB is touching the head of minus VA, join the third side. The third side gives you the resultant. That is addition of two vectors. That means it will become VB plus minus VA. That's nothing but VB minus VA. So this is according to the triangular law of vector addition. According to the triangular law of vector addition, if two vectors, this is A bar and another vector B bar, it's touching like this. Here head of B is touching the tail of A, then join the third side. These two are going in this direction, so the third side will be in this direction, that is A plus B. This is triangular law, we know that. In the same way here, this is VA bar and this is VB bar. The head of A is touching the tail of B, and if you join the third line, the third side gives the addition of them, but here it is minus VA, so you will get VB plus VA with negative sign. That means VB plus minus VA, therefore you will get VB bar minus VA bar. This is what I have written here. Hope you are following. So this is what I have written here. So try to understand the same vectors, that is the velocity at the point A is VA bar, velocity at the VB is B is VB bar, and we have taken the VA in the opposite direction so that we can get the third side as subtraction, that is difference of the velocities VB bar minus VA bar, that is change in the velocity which we have taken as dV bar. So next, let us continue. The same thing I have explained here in writing. Let VA bar and VB bar are velocities of the particle at the points A and B respectively. Let dx be the linear displacement of the particle in time dt. Let VA bar and VB bar be the velocities of the particle at the points A and B respectively. Already I told you, at A it is VA bar, at B it is VB bar. And dx be the linear displacement. This is dx, be the linear displacement. And let d theta be the angular displacement. This is the angle which is d theta. And this is all took in a time of dt. So everything happened in the time of dt. So change in time in dt, change in linear displacement is dx, change in angular displacement, that is change in displacement is d theta. That means dx is the linear displacement, dt is the time duration, d theta is the angular displacement in this time dt. So in this figure we have taken this vector subtraction here. Already I have explained you, that is VA we have taken in negative direction minus VA, head of minus VA is touching the tail of VB, it makes a triangle, so the third side of the triangle gives you VB bar minus VA bar. So dV bar is equal to VB bar minus VA bar. dV means change in velocity is equal to VB bar minus VA bar. So let it be dV. So let's keep it like that and continue. The directions of dV bar and the centripetal acceleration are same. You can see in this figure, dV bar is in this direction, in this figure. The same above figure we have taken VA and VB and we have made this triangle. Now AC is also in this direction. This is the direction of centripetal acceleration. This is the direction of dV bar. So you can, both are same, that is you can see in this picture from top to down. So the triangle OAB, the triangle OAB, this triangle, and the triangle PQR, both are similar. For similar triangles, similar means you already know in mathematics, there are certain rules for similar triangles, side angle side, like that we have some rules. If the ratio are same, we call them as the similar triangles. So that is from mathematics. These two triangles are similar. Therefore, in the similar triangles, the ratio of three sides is equal. If you take the sides of the triangle, ratio will be equal. That means ratio of three sides of one triangle with respect to the three sides of another triangle is same. This is all mathematics. Ratio of the three sides of one triangle with respect to the three sides of another triangle is same. That is QR by PQ, that is QR by PQ. QR by PQ, that is equal to AB by OA. AB by OA. Because here AB, OA and OB are same in magnitude. Here also VA and VB are same in magnitude but not in direction. And then in between them is dx, in between them we have dv. That is AB is similar to QR, and PQ is similar to OA. Therefore in a similar triangles the ratio is same, so we are taking QR by PQ is equal to AB by OA. Then let's continue our discussion. That is QR by PQ is equal to AB by OA. AB by OA. So let's go back. You can see from there, you can see QR by PQ is equal to AB by OA. QR by PQ. QR means DV. QR means DV. PQ means minus VA. Anything with magnitude VA. Again, that is AB is DX and OA is R. So DV by VA is equal to DX by R. So here same thing we have taken. DV by VA is equal to DX by R. DV by VA is equal to DX by R. Because VA is equal to VB is equal to V in magnitude, we have taken DV by V is equal to DX by R. So this I have written here. VA is equal to VB is equal to V in magnitude. Then send V to that side, you will get DV is equal to V dx by R. Let it be equation number 2. Let it be equation number 2. So this is equation number 1 and this is equation number 2. Then, but centripetal acceleration AC is equal to dV by dt. We all know the definition of acceleration is rate of change of velocity with respect to time. So therefore AC is equal to dV by dt, equation number 3. Now substituting 2 in 3, bring this equation, substitute here. dV in place of dV, we will write V dx by R. This we have written here. In AC is equal to dV by dt, dV by dt. So in place of dV, we write V dx by R. This we will write V dx by R. And dt was already there. This dt is here and this dt is here. So once again substituting the equation 2 in 3, that is dV value we have substituted in centripetal acceleration formula. Then you will get AC is equal to V by R dx by dt. But dx by dt is V again. So replace dx by dt with V. Therefore it becomes V into V by R, which is V square by R. This is the expression for centripetal acceleration, equation number 4. Equation number 4. Up to this it's enough, very important. And we will also take another formula for that, which will be useful for our numericals. We all know the relationship V is equal to R omega. This we have derived just now. Here only this, here we have derived it. So here we have derived this. V is equal to R omega. So let's use it. And continue. So this is this one. V is equal to R omega. V is equal to R omega. Substitute V value here as R omega. So in place of V square R omega whole square you will get, it becomes R square omega square by R. One R will be cancelled, then R omega square. Therefore AC is equal to omega square R. This is another form of centripetal acceleration. So this is, uh, you can see here, AC is equal to omega square R. Here AC is equal to V square by R. So AC is equal to omega square R, AC is equal to omega square R, and also AC is equal to V square by R. And then this is another important formula. Now force is equal to M into A as per Newton's second law. Therefore M means mass, A means acceleration. Here it is a centripetal acceleration. Therefore we keep the subscript C, that is MA with subscript C we write. F is equal to MAC. Substitute the value of A here. Substitute the value of A here, that is substituting equation 4 in 6. F is equal to M, A place you are writing V square by R. So you are getting MV square by R. You are getting MV square by R. So we have seen many expressions today. The first expression is V is equal to R omega. The first expression what we have done is V is equal to R omega. Second one is AC is equal to V square by R. And third is AC is equal to omega square R. And the fourth is F is equal to MV square by R. Remember these formulas. These formulas will be very much useful when you come to that chapter, that is the 7th chapter, System of Particles and Rotational Motion. So it is also useful for rotational motion. When we come to the chapter of rotational motion, all these formulas we will be using again. So learn them. So the first, here itself you have to learn. First formula we learned today is equal to, is V is equal to R omega. Second one is AC is equal to V square by R. Third is AC is equal to omega square R. And the last one, F is equal to MV square by R. This one. So with this we have completed our all formulas and derivations of circular motion. Thank you for watching this video. Let's meet with another video in the next class. Until then, bye. God bless you all.